And for this module video, we're going to go ahead and sort of work through the SolidWorks interface a little bit, as well as jump right into some sketching. So I've already got SolidWorks open here on my screen. And to get started with our talk about the interface, we sort of need something open in order to talk about. So I'm going to head on up here to File, and I'm going to click on New. And Part is selected by default. Now this new document window will show me by default whatever it was that I last worked on. So if I had worked on a drawing last, it would want me to make a new drawing. So you may have to click on Part depending on where you left off your previous SolidWorks session. But I'm going to leave Part selected here. I'm going to click OK, and SolidWorks will create a new part document for me. And once everything comes up, I've got now a blank part document. This is what things look like. So along the top here, we've got a ribbon with all of our sketch commands. And because we've started with a part and the part is empty, the sketch tab comes up automatically by default. We've got some other things here, mesh modeling, data migration, some things that we don't really need yet. Features could come in handy. But for now, we're going to stick with this sketch tab, right? So important to note over here on the left is our part tree or project tree. This is a listing of all of the features that we add to a part. Right now it's empty. We don't have anything in here except a couple of default planes. For SolidWorks, the front, top, and right planes are created by default with every new part that we create. And I'm going to go ahead right now and show you the way to show those. Right now, my viewport window, the area where the part will be, is empty. But if I come over here to this model tree and if I right click, I get a context window and there's a show button here that I can click, and now all of a sudden that plane becomes visible. And if I do the same for all of these, I can show all of the planes. Now, by default, I've been messing a little bit with my default setups here for some other work I've been doing, but by default, these should pop up looking a little bit more even, as in centered on your screen, a little bigger here, a little bigger here, right? And something like this. So, but we've got three planes, and these planes correspond to directions in three-dimensional space. If you look in the model window, that's this window where the planes show up again. Down here in the bottom left is an XYZ coordinate system. So if I center click on my mouse, I can rotate this. You see my XYZ rotates along with the planes. So center clicking, that's your scroll wheel, and pushing it down is how I go ahead and rotate this. And that's how I can get a different view of these things that are here. So important to note that in today's world, where quite a few of the things that we will be designing are probably intended to be 3D printed, is that top, front, and right don't make a whole lot of sense in terms of X, Y, and Z. So I think what most of us would consider the Z axis to be up. And if we look at this XYZ coordinate system down here, we notice Z isn't, facing the top plane. Z is actually facing the front plane. And if we're designing a part to be 3D printed, that's an important thing to note, because we can actually, if we design the part up from the front plane, say in the direction of this blue Z, then our 3D printer will automatically see the front plane as the print bed. So the recommendation there would be that if you're designing parts specifically to be 3D printed, that you design primarily on the front plane, which is different from, frankly, how I usually work. And a lot of conventional wisdom on SolidWorks would have you work on the top plane. And the reason that we would work on the top plane is because the way you see my screen right now is sort of the way that SolidWorks will default orient our parts later if we ask it to go into, say, an isometric view. So along the top of our model window here, we see this whole list of icons, right? If I go to view orientation, I can select a whole bunch of different things, right? I can select corners even to view and give me the proper view of my part. That's how we can quickly get to orientations we want. But if I select just a simple isometric view right here in the corner, see, it's going to orient it where it views the top plane sort of as the floor by default. Um, and again, that's backwards from 3D printing. For 3D printing, again, I recommend that we start in the front plane. And given that your project for this course involves parts that are intended to be 3D printing, that's exactly where we're going to start. So we're going to start on this front plane. And actually, first, I'm going to start by re-hiding all of these guys over here in my model tree. Okay. I don't need to see them in my model window because as I click them or highlight them in the model tree, they pop up anyway. So these planes are okay to be hidden. Now later, I may want to be able to see the plane so that I know exactly what types of things I'm working with. And it'll get more important when we get into more complex modeling topics. But for now, for sketching, I'm just going to come over here and select the front plane. And I'm going to come up to the ribbon. The very first icon on this sketch tab is sketch. It's going to orient my front plane, and I'm going to make it bigger. Again, I was messing with the size here, but it's going to orient my front plane to be facing me so that I can now create a two-dimensional sketch on this front plane. So sketching is really important. Sketching is the thing that most of our features in a SolidWorks model are going to be based on. So having a really firm grasp of sketching, making sure that sketches are fully constrained, or later on knowing when to break the fully constrained rule to leave a sketch that's not fully constrained, all of that stuff is an important factor in making good parts that are easily modifiable later. They are easy for us to move into a manufacturing setting, etc. So when it comes to sketching, the plane, again, I was messing with mine, should be centered with the red axis here, and that indicates 0, 0. Notice my XYZ is still down here in the left, but this indicates 0, 0 on the XY axis. If I click origin over here on the model tree, right, it highlights that dot as 0, 0 in X and Y. So what is a sketch? A sketch is a series of geometric objects that draw the basic shape of our part, right? And we can use a sketch to either later on create an extruded shape, a revolved shape, swept shapes, everything. Everything we do is primarily based on a sketch. So it's important, again, to understand how sketching works. So for this quick demonstration, I'm going to grab just a line. Again, up here on the ribbon are all of my sketching tools. And for now, we're pretty much going to be living in this second section on the ribbon where we've got lines, we've got circles, splines we will talk about later. We've got rectangles, all of the basic shapes we could possibly use to build out our parts. So for now, to demonstrate sketching, I'm going to grab a line and I'm just going to draw it at random out here in my model area, in my model window. So I've got a random line, right? Now, we all know, or at least I hope that we all know, that engineering parts are not random, right? We don't just draw lines in the middle of nowhere. Okay, so I've got a line out in random space. And if I click on it, I now have a line properties tab over here that's opened up in place of my model tree. I can still get to the feature manager, right? The model tree, the feature manager, by clicking these tabs up at the top. But by default, when I click the line, when I select it and deselect, it automatically switches between the feature tree and the properties window. So here I've got relations. We will see those get populated here in just a moment. I have the ability to add relations here. I've got some options, for instance, whether I want it to be a construction line or infinite length. And then I've got the length and the angle of the line. So if I can change either one of these, right now it's telling me it's a little over 11 inches long. If I change this to 5, we will see the length of the line change in our model window. Likewise, if I change this angle, it moved it, but it also made it, sort of horizontal. If I go 90 degrees, again, it moves. And to zoom out the way I am, if I zoom out, I'm just scrolling that middle wheel, right? Pushing the middle wheel rather rotates my model view. Scrolling it zooms me in and out. So I want to bring this back up here somewhat randomly. I'm going to make it random again and bring it back closer to my origin just for the sake of discussion. So if I select the line, these relations are also what are known more broadly in CAD as constraints. Every sketch entity we create, every line, every circle, every arc will have a series of constraints. And what the constraints do, or the relations, or whichever terminology we choose to use, is lock that feature in place, that shape in place. So right now, notice that the line, when I deselect it, is entirely blue. Both points are blue. The line is blue. Blue in SolidWorks means that my sketch is not locked down, right? It is not constrained. I can grab the points and swing them around. I can grab the line and move it around. I can move this anywhere randomly that I want, right? It is a series of relations or constraints, or whichever terminology again we prefer. I prefer constraints that allow us to define that line in space. So first, I'm going to select this line as a demo, and if I want this line to be perfectly horizontal with my viewing window, I can click over here on the Add Relation Horizontal Constraint. And we see there's now a horizontal relation here in the existing relations window, and I've gotten this green box now indicating with a line that I have placed a horizontal constraint on this line. So now when I can still move the line because I haven't done anything else to define its position, except tell SolidWorks that this line needs to remain horizontal at all times. So no matter which end I grab and drag around, if I drag the line, all I can do is move it up and down. It's now constrained horizontally. If I want to get rid of that, it was in error, I can either click the existing relation, which will highlight it in the model window in purple, and I can click delete, right? And now I can move my line around freely again. The same thing for SolidWorks, notice these are bolder. The same thing works for vertical. I can vertically constrain it. But SolidWorks, and the other way to delete, by the way, is if I click the green box, when there are, say, 100 relations in this list, it can be hard to determine which one you want to delete. If I just select the green box, I can also delete it without affecting the rest of my line. SolidWorks, though, if I restart somewhere close to where I was, SolidWorks bolds these relations, these recommended ones. It sees that this line is flatter than not. So it will bold the horizontal relation. That's what it thinks you want. If I make this closer to vertical and select the line, now it suggests the vertical relation. So that's one form of constraint. Do I want this line to be horizontal or do I want this line to be vertical? If, stick with our horizontal relation and add that. So this line, we know we want it to be horizontal all the time, right? I can still move it around. It's still blue. Blue means nothing is really fixed. All I've done is I've stopped the line from rotating. So typically, and there are a lot of reasons where this rule might be violated. It's why I hesitate to even call it a rule. Typically, we want to start our drawing somewhere around the origin, right? Somewhere around zero. So typically, with a line like this, especially if this is the first line we're drawing, we want to make this point coincident with this point. We want to make this point zero. Now, I could move it down here, or I could control click both points. Now notice if I control click the end of the line and zero, the origin, I now have not just horizontal, vertical, and coincident. I have coincident added down here, not just horizontal and vertical, rather. So vertical, in this case, again, SolidWorks is making a recommendation. It thinks I want it vertical because I'm nowhere near the origin. If I click on vertical, notice I'm still blue. I now have the green icon indicating I have a vertical constraint with a vertical line. Notice the horizontal is a horizontal line, vertical is vertical. I can still, though, move this up and down because all I've told it to do for now is lock it vertically in reference to zero. Right? This point, I can still move around everywhere, anywhere I want it to be because I haven't done anything to constrain this. So I'm going to delete this vertical because more simply for especially again our first shape, typically we want it to be coincident with the origin. Now, a couple of things happened there when I clicked on coincident. First of all, the line jumped down to 0, 0 because I have locked it to be horizontal. And this point is now forced to always be at 0, 0. That's what coincident means. It will always be fixed to that location. The line itself, along with this point can no longer move. If I click it and pull and drag, see, cannot drag. The selected item is fixed. So that's locked down. If I click the line, I can't move it around either. I'm dragging right now and the line's not moving. So the point and the line itself are now black. That means they are fully constrained. I cannot change that point. I cannot change that line. Now, if I wanted to delete, if I select my coincident to delete it, now I go back to blue and all bets are off except for my horizontal constraint. So if I can also create a coincident by dragging it and notice the little coincident icon that pops up next to my cursor when I release, it adds that coincidence. That is typically something it's okay for these first few shapes that we put in a sketch. As the model gets more and more complex and our sketching gets more and more complex, really want to do the other way, the first way that I showed with control clicking the 2 points. It's safer. There's less things in the way. If I have a bunch of circles and arcs and other stuff where I want to drag this point, there's a lot of other things that SolidWorks will try to snap to. So I don't want to get into that trouble. So I recommend typically using the control click and selecting both points and hitting coincident. Right, so that point now is locked down. The line position is locked down. That's why the line is black. But notice that the point way out here is still blue. We'll zoom in a little. The point's still blue because I can still drag the line. I haven't done anything to define the length, right? I can do that a couple of ways. One is by defining the length here, right? That's 12 inches long now. The problem with that method, notice when I deselect my line, is that even though this is 12 inches, I can see that over here in my properties, it didn't lock this point down. I can still drag it. SolidWorks does not consider the entry into the properties to be the true length of the line. I need something else to define how long I want this line. And I do that here by clicking up in the ribbon under Smart Dimension. So I could click Smart Dimension. I can click this point and this point and bring my dimension down. It automatically pops up. It wants me to input. So what you're looking at now, the 18.94 is the length that that line is now in inches. And it automatically wants me to input the length that I want. So let's stick with 12. I want it to be 12. Enter. The line is now 12 inches long. And notice that that point is now black. If I click it and try to drag, I can't go anywhere. It's locked down. It's been told that this end of the line is at 0. The line has to be horizontal. And I've now defined a length for this point. So the sketch itself, everything is now black, and that's what we call fully constrained. And that's going to be a key feature with some of your upcoming exams and project is that for these starter parts anyway, we expect fully constrained sketches. I expect to be able to open these sketches and see everything that you've drawn in here to be black. That means it's fully defined, it's locked down. I can't get in here and accidentally drag it around and mess up the part in the future. So that is sort of the basics of constraints. Let's go a step further. Let's say that I would like to draw some sort of an arc on the end of this line. Up here on the ribbon, I have 3-point arcs. But if I click this little drop down, I've also got a center point arc, a tangent arc, and a 3-point. Now this ribbon will change. For instance, line has a couple of choices as well. This ribbon will change based on which I used last. And I will say probably 95% of the time I'm working with 3-point arcs here. So that's why mine says 3-point arc. If you're booting up SolidWorks for the first time, here's my default to center point arc. And the difference is just how we draw it. So let's switch to a center point arc. A center point arc, I'm going to click, and that first thing I clicked, notice I don't actually have a solid line anywhere when I'm moving my mouse around. I just clicked once to drop a point. That point is the center of the arc. So with a center point arc, that's the first point I'm going to define, is the center. Then the second point, which I haven't clicked yet, the second point is going to be the start of the arc. So let's start it at the end of our line. If I click here. So now as I pull, I'm not dragging. I've clicked just once, just a single click. I can drag this arc around to any angle I want. All right. So if I click one more time, now I have again over here where the model tree was, the feature manager, I've got arc properties, right? Existing relations. There really are none because I haven't defined any yet. Notice it's telling me it is underdefined. That's a quick check to say that it's under constrained. It's not fully constrained yet. Because again, if I click, this point is constrained. I started at the end of my line. I can't move that. It is fixed to 0, but I can still move this. And notice as I move this point and drag it around, the radius changes, the diameter changes, everything changes, right? I can also click and move the center, which changes everything. So this circle, or this arc rather, is definitely under constraint. So one of the more common constraint types for an arc is a tangent. So if I click the arc and the line, so that I've got them both selected, right? Selected entities over here says arc and line, right? They are both selected. Down here, I now have a tangent option. If I click that, let's make it very obvious before I click that. Let's move this so that angle is, and I'll zoom in for a better view. So if I select both now, and I want to make that tangent, very obviously, there's a bulge here, right? This arc is not tangent to my line. A tangent constraint, notice the icon that popped up here near the point, because the point is where tangency applies, forced that circle now, or that arc rather, to be tangent. So I can still move. It's still blue. I'm not fully constrained yet. So I can still move these points and the center point around. But no matter what I do now, I will not get another bulge because I'm forcing that arc to be tangent to the line. So there are a lot of examples, things that I could go through here with how to define an arc. I will say one of the more common constraints is a vertical constraint now. So if I were to say, let's say that, for instance, this were the end of a wrench, right? The back end of a wrench, we want it nice and round so that we don't stab anybody. I would select the top point, the center point, and I'm again doing that by control clicking, and 0. And I can constrain those all to be vertical. So now I know that this point where I would continue my sketch is directly above 0. Right? It's directly above the 0, 0 point. It's still blue. I'm not fully constrained because I can still drag it and move it. And when I do this, it changes the radius and it changes the position of that point. But no matter where I try to pull my mouse, I can't get it off of that vertical. So that's a pretty common constraint that we like to use for arcs. Okay. So that said, let's give it now the last piece that an arc needs to be fully constrained, and that would be a radius. So again, up here, I'm going to hit Smart Dimension, and I'm going to click the arc itself. And when I pull it out, notice I've got a radius on my mouse. If I click to drop that in, again, it pulls up. It wants to know, what do you want the radius to be? In this case, if we are 12 inches long, let's go with a 0.5 inch radius. Seems reasonable as I'm making this up on the fly. Right? Notice now it shrunk significantly, but we now have a radius, right? We have an arc there on the end of our line. Now we could close this in and do more sketching of this nature, but this is the key to constrained sketches is we want to make sure that those points can't move, and SolidWorks gives us a good double check by um, turning things black for us. And when we click here and get into the properties, we also see fully defined now. Once it turns black, we'll see fully defined here under the existing relations. So that's sort of a simple, very simple overview of sketching. Now, we can continue this. I will point out some of the pitfalls. Let me grab a line here up at my ribbon. When we go now, the first line was fairly easy to draw, right? We only had the origin here to draw from, and I drew it randomly, and then I constrained it. As these sketches get more and more complex, there are now one, two, three, four, 5 points, and actually there's six because this one's not showing right now. 6 points in this sketch, right? We can grab the center, which we didn't draw the center of this arc, but that's a point that SolidWorks automatically gives us, so we can reference from it. For instance, if I want to make sure that I've got a line that needs to come directly from this center, I can click it. Now notice I've already got the line selected, but I can click it and draw from there, and I have a coincident to the center of that arc, and that point's never moved. Get rid of that. But as things get more complex, again, select the line. SolidWorks is going to want to automatically snap to some of these things. And when I do that, occasionally, now it did not in this case, but occasionally what we will run into is it will automatically throw a horizontal relation in here. And that's a thing to watch out as your sketches get more and more complex. Because what can happen then, if I say grab this, well, let's add a dimension. I need to force this to break. So I'm going to grab the center of my arc and the line. Now I know the radius is a 1/2 inch, and I'm going to hit enter and try to drop a dimension in there, right? It's telling me adding this dimension will make the sketch over define, right? Because this radius out here, the one I drew or the one I added first, is already defining the size of that arc. Over define means I'm now trying to control the radius with something else, right? That can happen with either dimensions. It can also happen if I try to throw too many constraints on a thing. So it's something to watch out for. What I can do is I'm going to actually cancel that. If, for instance, I don't really care about the radius, right? The radius is the distance from here, from the center to the line, correct? It's half of that arc. I don't care about that so much. Say I care about this if this were a handle for a wrench. I care about the thickness. So I can draw a dimension from here to here. I will be over defined because the diameter is also trying to define the radius. They should match, right? The diameter should be exactly double the radius. But the problem is I can't define both. So what I can do is I can leave it as a driven dimension. And I'm going to hit OK on that. And actually, it grabbed the wrong thing. I want you to give me the height. There we go. And so I want to leave it driven because the 1 inch is what I care about, right? Now, in actual practice, I recommend, I mean, occasionally you'll run into things where you need driven dimensions. You'll want to see, all right, what is the gap here? Even though I'm not defining the gap, I'm dimensioning, the piece of metal that exists. I need to know the gap between two pieces. So that's where I might use a driven dimension. But I recommend, if possible, if it's a dimension you really need to know that you really care about, that you use that one to drive your sketch, right? Rather than driven dimensions. But this is how a driven dimension works. If I were to change this now, I can change this dimension just by double clicking. And if I make it 1 inch, notice my driven dimension changed to 2 inches. So driven means that SolidWorks will automatically update it so that I can then see what that dimension actually is. So If I need it in this case, again, I'm going to double click and go back to my 1/2 inch just because that looks like it fits better. But if I really, really cared about that thickness instead of the ratings, then that would be a good case to use a driven dimension, because then I can see it all here on my sketch and I can adjust the radius to give me the thickness that I want, the diameter that I want. So that is a primer on sketching and locking things down.